Good morning everyone. Welcome to the course on Network Theory, and this is Dr. Satyavani Bandela, Assistant Professor, SR University, Warangal, Telangana. In today's lecture, we are going to discuss mesh analysis in DC network. In previous lecture, that is in lesson number 1, we discussed introduction to electrical network, different types of electrical elements, classification, units, and how the elements are represented. Those things we are discussed in lecture number 1, and in second lesson, that is lesson number 2, Ohm's law and the basic circuit elements with the power and energy calculation. And in lesson number 3, we discussed Kirchhoff's current law. Let me give again the statement of Ohm's law, Kirchhoff's current law. Now, Ohm's law states that provided at constant temperature, current to the conductor is directly proportional to voltage, and the derived formula V equals to IR. So, that part we discussed, and because we have to in next lecture we are going to use this equation, that is V equals to IR formula, and the next the power equation P equals to V into I, and the energy it is product of power and time. So, these are the three basic equations, and using these equations we are going to calculate whatever the question that is asked in the problem, that is whether that is voltage, current, resistor, equivalent resistor, or electrical power. Okay. And Kirchhoff's current law states that in lesson number 3 we discussed Kirchhoff's current law. According to Kirchhoff's current law, it is algebraic sum of current at node equals to 0, and the node definition it is stated that the point at which two or more elements connected together. Even that node is also known as a junction. So, this KCL is applicable at node. Okay. So, this we discussed, and with a few problems. Then in fourth lesson, Kirchhoff's voltage law and algebraic sum of voltages. According to this law, algebraic sum of voltages in closed circuit equals to 0. Okay. And few problems we solve. If you want to know about these things, you just go through my previous lecture 3 and 4 about KVA, Kirchhoff's voltage law and Kirchhoff's current law. And in lesson number 5, we discussed series and parallel network, how the elements are connected and what are the properties. See, if the elements are connected in this manner, here I am taking two resistors, and if the elements are connected in this manner, then these two elements are connected in series. Okay. So, this type of connection is said to be series connection, and the property of series connection is the same current flows, because whatever the current that is flowing through this resistance R1, the same current is flowing through this R2. So, current will be the same, but voltage division takes place. Okay. So, if the voltage, let us take the voltage is applied across this one is some V, and here the voltage across R1 is V1, and where that V1 is a product of current I into R1, and the voltage across this V2 is product of current and resistance R2. So, they may be same or different voltages, but this total voltage is divided into two parts, V1 and V2. So, the property, finally the property of series network is same current and voltage division takes place. And the next property, the next type of connection, here it is parallel. So, when two elements are connected in parallel means, if the first end of these elements are connected together and the second ends are connected together, if they are extended with this, then this type of connection is said to be parallel connection. Okay. So, here in parallel connection, if the current delivered by this voltage source is said to be I, and this current is divided into two parts, the voltage across R1 and R2 is the same. So, voltage is same, but the current is dividing. Is it right? So, in parallel circuit, the property is same voltage, but current division takes place, current is different. So, these are the properties, and even if three resistors are connected in series, like what is the equivalent resistor? R1, R2 plus R3. Sum of the elements, sum of resistive magnitudes you have to take. If two resistors are connected in parallel, or n number of resistors are connected in parallel, we have to take the equation R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by up to Rn, if n number of resistors are connected in parallel. If n number of resistors connected in series, the equivalent resistance is R1 plus R2 plus R3 up to Rn. So these are the basic formulas that we studied, and we solved a few problems on series and parallel network in previous lecture. Now in today's lecture, we are going to discuss mesh analysis in DC circuit. Now see the properties of mesh analysis. Mesh analysis is a loop that does not contain any other loop within it. So means the mesh is considered as, in this example, here it is a loop. It is in this loop, it is a combination of voltage R1 and R3. Okay, so it does not contain any other loop within it. So this is this combination of the combination of these three elements in closed circuit, that is said to be a mesh. So this is your mesh example in this network. And this mesh analysis is another general procedure for analyzing circuits using mesh currents as the circuit variable. And this mesh currents instead of elements currents as circuit variables is convenient and reduces the number of equations that must be solved in simultaneously. Okay, so that this we will see while solving the problem. And the most important property is the mesh analysis. Mesh analysis applies Kirchhoff's voltage law to find unknown currents. See here, the mesh is nothing but it is used. What is the purpose of using mesh analysis? Actually, the basic purpose of mesh analysis to find mesh current. Mesh current. Okay. So mesh is nothing but closed path. Okay, we can also call it as loop current. Mesh current or loop current. Okay, so the purpose of using mesh analysis to find, first step is to find the loop current. What is the loop? Just now we discussed. So this is the closed part in the network, and in that loop the current is represented with I1. So this current is a loop current or mesh current. Okay, so using mesh analysis we can find out this loop, that is I1 current, as well as in second loop I2 current. Okay, and after getting these loop currents, we can determine the branch current. So what is meant by branch? So this is the element which is connected between 2 points. Here this is one of the branch which is connected between B and C. R2 is a element which is connected between B and C element, and this is a branch. Okay, in this branch whatever the current that is flowing in this case is same as the loop current. Okay, and the same I2 current is flowing through this branch from B, C, D and E. So this branch current is same as loop current, and here from here E and the voltage and through R1, this branch current is same as this loop current. But whereas in case of R3 resistance, in this branch this current is not same as either I1 or I2. So how do you get this current? And this current is taken the difference between two currents, because it depending on the direction of current where you are taking in loop 1 and in loop 2. That we will see in, by taking one example circuit. Okay, and now look at this. Here I am taking one example circuit, the mesh analysis. Let us take one circuit fresh page. Now see, here I am taking one example network with two voltage sources and three resistors. Okay. Now see how to solve or how to find out loop currents and what are the steps that we need to follow to find out these loop currents. Now see the first step. So assign mesh current I1, I2 up to IN in N mesh. Means if any network, let us take here, I am taking one more network. This is one voltage source. Here it is like this, and here one more, and this is another one. Okay, if I take another one like this, see here. So this is loop 1, and this is loop 2, this is loop 3, and this is loop 4. Means here n is 4. There are 4 loops. So that's why first thing is identify number of loops and represent loop current with first loop current with I1 in clockwise direction. Here I am taking clockwise direction, and you can also take anti-clockwise direction, your wish, but we will follow the same. For any problem, for further problems, we will follow the we will take the same direction in clockwise direction. Okay, and here in loop 2 the current is represented with I2, and in loop 3 I3, and here it is I4. So like if n number of loops are there, you can take I1 up to IN loops. So this is the first step while performing your mesh analysis in any network. Okay, then next apply KVL to each N mesh. Okay, now here though we are representing currents, but the mesh analysis is an application of Kirchhoff's voltage law. So in every loop we have to apply KVL, Kirchhoff's voltage law. What is Kirchhoff's voltage law? It is algebraic sum of voltages in closed circuit equals to 0. So that we will apply in each and every loop. If you have 2 loops, you will get 2 equations. KVL in one loop 1, one equation. KVL in loop 2, second equation. If n number of loops are there, you will get n number of equations by applying mesh analysis. Mesh is nothing but indirectly it is the application of Kirchhoff's voltage law. Then the next step is solve the resulting n simultaneously equations to get the mesh current. Means if whatever the equation that you are getting in loop 1, first equation 1 you will get applying KVL, and here in loop 2 you will get equation 2. Now solve these 2 equations so that finally you will get the current loop current I1 and I2, because 2 unknown parameters I1 and I2, 2 equations you have. So to find out to calculate 2 equations, to get 2 unknown parameters, we should have 2 equations. Okay, so that's why here by applying KVL in every loop you will get n number of equations, and we can find out n number of currents. Okay. So these are the steps that you need to follow while applying mesh analysis. Okay. Now here let us discuss. Here I am taking the same problem. Now see how to apply mesh analysis in this network. Let me erase this ink marks. Now I will follow the same steps and I will write KVL equation for this network. Okay, so what is the first step according to these instructions? What is the first step? Step 1 is, let me take different color. Here I am taking blue color. Now step 1 is identify number of loops. So this is loop 1 and this is loop 2, and in loop 1 represent current with I1, and in loop 2 represent current with I2. Okay. Now observe, here I am taking clockwise direction. In loop 1 clockwise direction, and in loop 2 also clockwise direction. Okay. Now see, so loop 1, you start from here, from F, and cover all the elements F to A to B, B to E, E to F. Okay. See the path from F to A and A to B, B to E and B, E to F, again the starting point. Okay, so this is your loop. Now in this loop, look at the elements. What are the elements? One voltage source and two resistors. Okay, so one voltage source, this is the voltage source, and two resistors R1 and R3 are there. Okay, now see how to apply Kirchhoff's voltage. Now apply KVL. Mesh analysis is nothing but application of KVL in this loop. When I apply KVL in this loop, now see, this is minus to plus. This is our direction. Actually we are moving in this clockwise direction like this, starting from F. Now from F to A, we are crossing this voltage source from minus to plus. Okay, so when we are crossing this voltage with from minus to plus, we have to take plus V, and here it is represented with V1. That's why here I am writing V1. Okay, now F to A part is completed. Then from A to B, what is the element that is there in between A and B? Resistance. So resistance means what is the voltage? We are writing voltage equation. So what is the voltage across this R1? So voltage across this R1 is current into resistance. Okay. Now what is the current? Here already we discussed loop current, which is same as branch current. So now this can be written as I1 is the current, which is same as the loop current, small I1 here. Okay. Now voltage across R1 is, that is V1 is small I1 into R1. Now here I am writing minus, because this is our direction. That's why always according to our direction, the drop across the resistance is taken as plus minus polarity. That we already discussed in Ohm's law. So right. Okay. In KVL we discuss these things. Okay. Then next, here I am writing small I1 into R1 is the voltage drop across this element. Okay. Now we finished A to B part. Then from B to E, what is the element in between B to E? R3 is there. Okay. So R3 is nothing but resistance, and the direction of current here I am taking like this. Okay. But this element is connected between two loops. Neither I can take I1 or I2. So what should I take? What is the current? Now when we are applying KVL in this loop 1, then we have to take minus, the current is I1 minus I2. Okay, because I1 current is downwards like this in, and here I2 current is like this. We have taken in clockwise, means here it is upwards and here it is downwards. Okay, so that's why this is the current that is flowing through R3 into R3. Okay, now from E to F, is there any element here? No element. So no need to write voltage. Okay, so there is no element. F point is same as E point. No element, so no voltage drop. Now three elements are there, three voltages we got, and equals to 0. Algebraic sum of voltages in closed loop equals to 0. Okay, so this is our KVL in loop 1. Okay, what are I1 and I2? I1 and I2 are mesh currents or loop currents. Okay, later we will see what is the branch current. Now here I am writing, I am taking another color, red color, for loop 2. Look at this, loop 2. In loop 2, now see here I am starting from point E. Okay, from point E to B to C to D and E. Here let me write the path E to B, the next C, D to E. Okay. Now in between E to B, the element is R3. Okay. Now this is our direction. Let me erase other ink marks here. Okay. Now look at this. see, red color. Now this is our direction. How we are, this is our direction, clockwise direction. Is it right? Okay. Now in our direction, the current voltage drop across R3 is taken as R3 into current. What is the current now? When you are writing equation in loop 2, you have to take I2 minus I1. Because earlier when you are writing voltage drop across R3, we have taken R3 into I1 minus I2. So this is R3 into I1 minus I2 when you are writing in loop 1. But when I am writing voltage drop across R3 in loop 2, you have to write R3 into I2 minus I1, because if I am writing equation in loop 1, then it is considered as I1 is greater than any other loop. When I am writing KVL in loop 2, you have to consider current I2 is greater than remaining other loop currents. So that's why you have to take I2 minus I1. So here the first element is R3 into I2 minus I1. So this is the resistance drop, that's why minus voltage drop. Okay. Then after this, one more resistance R2. So that's why minus R2 into what is the current? So this current is same as the loop current, that is I2. Is there any other loop here outside this? No, that's why we have to take only I2. If any other current is there like this loop, there if I am taking I3, then you have to take I2 minus I3. There is no other loop outside this element, that's why you have to take current through this R2 is only I2. So here I am writing I2. Okay, then next, after this, what is the element? Voltage. Now in our direction we are crossing this V2 from plus to minus, we are moving plus to minus, that's why it is minus V2 equals to 0. Okay, so like this, first you try to develop equation, loop 1 equation and loop 2 equation, then later you solve these equations to find either current or voltage or any other parameter based on the data that is provided. Now we will take the same circuit with numbers, voltage and resistances. Now look at this. Okay, if I take the same network with a different with the source magnitudes, let us represent the numbers. Here I am taking, this is the 10 voltage source, 2 ohm resistance. I am taking simple numbers, 3 ohm resistance, 5 ohm resistance and 12 voltage source. Okay. Now, so the this part we already written in previous slide, and if I take minus as common, you will get this equation. Okay, and I will explain this is in simple form. See, we can write this as, first of all, better you write voltage sources and algebraic sum of IR drops right side. Okay, so you remember like this. So it will be very easy to write your mesh equation if you remember. Algebraic sum of voltage sources equals to algebraic sum of voltage drops across the resistance. Okay, now I will show this same, I will apply this same for this network. See here, in loop 1, okay, shall we discuss this the same? So when minus is taken, in previous slide we have written these equations. When minus is taken as common, we can write equation like this, and from here the voltage, only single voltage is there, that here I have taken algebraic sum voltage equals to, and IR drops left side. Okay, V equals to, this is your source voltage, and IR drops I am writing left side. Okay, and here in loop 2 equation, and this is your equation. It is like the previous slide we discussed the same equation, and this is equation 1 and equation 2, and these two equations can be represented in matrix form like this. Okay, and this is V equals to R into I form. So R matrix into I matrix equals to V matrix. Okay, if you multiply, so this is R1 plus R2 into I1, R1 plus R3 into I1 minus R3 into R2 equals to V1. Okay, so why we have represented this in matrix form? So in solving this matrix, you will get direct I1 and I2 values. If you have calculator, you can use this and you can do this matrix division. Then you will get direct I1 and I2 values. Okay, either use your calculator and you keep that calculator in equation mode and solve two unknown parameters I1 and I2, you will get direct answer I1 and I2. Okay, now here I am writing this same equation for the number voltage 10 volts, these three resistors. Now see this, let me take red color here. See, so this is our voltage source minus 2 plus, here I am writing the voltage source left side 10 equals to, then 2 into what is the current? I1. So 2 into I1 and the next element is 3. Okay, here I am writing right side. If you write this parameter left side, you have to take minus 2 I1, minus 3 I1, minus I2. But here resistor drops, voltage drop across resistors. I am writing right side, that's why I am writing plus 3 into, now what is the current? Because we are applying in loop 1. So the current is I1 minus I2. Okay, I1 minus I2. This is first equation, loop 1 equation. In loop 2, which one is the voltage? Which one is the voltage source? This is the voltage source. 12 is the voltage source. And in our direction plus 2 minus we are crossing, that's why the polarity here it is minus 12. Okay, remember. And the voltage drops across the resistors is all the positive. Here 3 into, now the current is I2 minus I1 and plus the next element is 5 into I2. That's it. Solve these two equations, and if you want we can write this equation 1 like this. Okay, so 10 equals to 5I1 minus 3I2 first equation, and this equation minus 12 equals to minus 3I1 and plus 8I2. Okay, solve these two equations and you will get I1 and I2 values. If you have calculator, you just enter these coefficients. How to enter these coefficients? First keep your calculator, select your mode of operation in equation mode. So set that in equation mode and select unknown unknown parameters. So there are two unknown parameters I1 and I2 are two unknown parameters. Okay, and these two parameters, number 2 is your unknown parameters, and select that unknown parameters, later enter the quotients. What are the quotients from equation 1? Let me write from equation 1. I think it is showing in calculator ax plus by equals to c. Okay, so here in equation 1 you have to take the first a value is 5 and equals to, it will take a, then next equals to means the second quotient here it is 3 and the third constant value it is 10 from this. Okay, 5 minus 3 and 10. Then in second equation the first I1 quotient is minus 3, I1 multiplicand is minus 3, then minus 3, and the second I2 multiplicand is 8, minus 3, 8, then next one is minus 2. So if you enter these all elements, 5 equals to, minus 3 equals to, 10 equals to, if you press equals to, then it will move to the second row. then minus 3 equals to 8 equals to minus 12 equals to, then again you press equals to, then you will get x value as your answer. What is that x value? Unknown parameter I1. So whatever the number that you are getting, that is your answer. Okay, and the y value in calculator, that is your I2. Right. So like this, you take one example problem and try to solve those example problems. You take your own number and solve those equations. Now in next lecture I am going to repeat the same, that is mesh analysis with different combination. Here this is the circuit with only two voltage sources. If any current is there, how to solve the network? If any current source comes in between two loops, how to solve that network? How to apply mesh analysis to that network? Okay. Now that we will see in next lecture, and until you just practice two loop equation. Okay. Thank you.